We're taking a look at computer systems, both hardware and software. So hardware typically consists of the CPU, it's a central processing unit, our main memory, any secondary storage devices, input devices, as well as output devices. When a computer is performing a task that a program tells it to do, the computer is running or executing the program. The CPU runs any programs. In the early days, CPUs were huge and they were made of vacuum tubes and switches. Now they are much smaller. Today's CPUs are called microprocessors and they're much smaller and more powerful. The CPU's job is to fetch instructions, follow these instructions, and then produce some result. The CPU consists of two parts. So CPU, we have the control unit and the arithmetic and logic unit. The arithmetic and logic unit is also known as the ALU. The control unit, this is the first part, coordinates all the computer's operations. It's responsible for determining where to get the next instruction and regulating the other major components of a computer with control signals. Again, the control unit does all of this. The ALU, or arithmetic and logic unit, is designed to perform mathematical operations. Now we'll take a look at the organization of a CPU. So first we are going to have some instruction. This is our input into the CPU. Remember, we have two parts, the arithmetic and logic unit, as well as the control unit. And then we have some result. This is our output. Programs are a sequence of instructions, and they're stored in our computer's memory. When a computer runs a program, the CPU engages in a fetch, decode, execute cycle. Fetch is where the CPU's control unit fetches from main memory the next instruction in the sequence of program instructions. Decode is where the instructions are encoded in a number. The control unit decodes our instructions and generates an electronic signal. Lastly, we have execute, and this is where the signal is routed to the appropriate component of the computer and it performs an operation. So again, we have our fetch, decode, and execute. Now if we look at the individual parts of our computer, our main memory is the computer's work area. It's where a computer stores a program while the computer is running and any extra data which the program is using. This is again the main memory, and the main memory is commonly known as RAM, or random access memory. It's called this because the CPU is able to access data stored at any random location in our RAM. RAM is usually a volatile storage, and it is used only for temporary storage. And it's when a computer is running, typically on. When the computer is turned off, the contents of our RAM are erased because it is volatile, a temporary storage. RAM is stored inside of our computers in individual small chips. A computer's memory is divided into tiny storage locations, also known as bytes. A single byte is enough memory to store a single letter, or a small number. Most computers today have millions or billions of bytes of memory. Bytes are then divided into 8 smaller storage locations, known as bits. So 1 byte is 8 bits, or 8 bits is 1 byte. A bit stands for a binary digit, and bits are a tiny electrical component that hold either a positive or a negative charge. Computer scientists say a positive charge is a switch on and a negative charge is a switch off. So think about it as like 1 is on and 0 is off. Each byte has a unique number, and this is known as its address. So just like a home, every home is unique and it has an address. Addresses are in order from lowest to highest. A byte is identified through its address. Next is our secondary storage, and it's a type of storage that can hold data for longer periods of time, even without power, so it is not volatile like RAM. Most common types of secondary storage is like a disk drive or a solid state drive. Traditionally, disk drives store data by magnetically encoding it in a circular disk, while solid state drives store data in solid state memory. They have no moving parts and operate much faster than disk drives. We also have USB, which is a universal series bus. We have SD, which is secure digital, and we can have these in memory cards. CDs and DVD drives use a laser to detect the bits and thus read the encoded data. Any input is any data that the computer collects from outside world. The device that collects the data and sends it to the computer is called our input device. Common input devices are like a keyboard, mouse, touchscreen, scanner, a digital camera, microphone, CDs, DVDs, or USB. Output is any information the computer sends to the outside world. So information is sent to an output device, which formats and presents it. Common output devices are like screens, printers, speakers, or storage devices. So we talked about the hardware. Now let's lastly look at software. Well, regarding software, everything a computer does is controlled under software. There are two types of software: system software as well as application software. Programs that control and manage the basic operations of the computer itself are system software. System software will often include any operating systems. These are the most fundamental set of programs on a computer. It controls the internal components of a computer's hardware, manages devices connected to the computer, and it allows data to be saved and retrieved from our storage devices, as well as allow other programs to run on the computer. We have utility programs which perform a specialized task, and it enhances a computer's operation of safeguarding data. These consist of like virus scanners, file compression programs, and data backup programs. Software development tools are software tools programmers use to create, modify, as well as test software. We have application software, and this is the other type of software for a computer. They're programs that make a computer useful for everyday tasks. So examples would be like Microsoft Word, PowerPoint, spreadsheet programs, web browsers in fact, email programs, or even games. These are application software, whereas system software is more related to the actual making sure the computer works.